Alright, here's some problems we've learned how to do prior. These were from lessons 4.1 and 4.3. So use the radius chord theorem to find the value of x. Now the radius chord theorem just basically tells us if the radius passing through a chord is perpendicular, then it cuts that chord in half. Okay, so if the whole chord is 14, then we know both sides are 7. Now we're looking for the value of x, but you'll notice x is a radius, right? It goes from the center to the circle. So from the center of the circle to this point here is x. You'll notice that right angle there gives us a right triangle, so we should be able to just write the equation a squared plus b squared equals c squared. Right, we know that the x value here, the radius, is the hypotenuse because it is opposite of the right angle. So in case you're ever like, ooh, which one's the hypotenuse, which one's the hypotenuse? It's the one that's opposite of the right angle. So to evaluate this, we get 36 plus 49 equals x squared. 36 plus 49, that's 55 plus 40, 95? Not doing that right, that's 85. Okay, yep, 85. So we take the square root of both sides, x should equal the square root of 85. And honestly, this should suffice. You can go ahead and type that into your calculator if you want, or you can simplify it if you're able to, but this should suffice. Obviously, knowing the number might help you to test it. Say 9.2 rounded is to the 100th is 9.22. I'm sorry, this says round to the nearest tenth. So we should type it in and discover that x equals 9.2. Is that reasonable, that x equals 9.2? Well, it's bigger than 6 and bigger than 7. So it could be the hypotenuse. And if you're really unsure, just check all your math. Make sure all your math is good. You guys know how to do this problem as well. The sides of ABC are tangent to the circle O. If AB is 20, so we really got to be in the habit of writing these out. AB is 20, AE right here is 12, and CF is 15. CF, that is right here. CF is 15. Now, with the tangent to the circle, we know that by the two tangent segment theorem, that these tangent segments that intersect, for example, DC and FC, they should be equivalent. We've proven this before. Same thing here. You'll notice that DA intersects with EA and they're both tangent to the circle. So this should be 12. Now, how do you figure out this value though, right here, BF? Well, BF is congruent to BE, and since we know all of that segment BA is 20, that blue segment, and we know that AE is 12, then BE must be the difference between 20 and 12. So this must be 8, which means that this is 8, since those are congruent segments. It's asking for AC. So AC we could have got a while ago. It's 12 plus 15, so 27. Alright, AB is tangent to circle O at point A. Use the tangent to a circle theorem to find the length of the radius to the nearest tenth. Okay, so now I'm reading clearly, round to the nearest tenth. Make sure you do that during a quiz. So use the tangent to a circle theorem to find the length of the radius. Well, we know, and this was actually one of the quiz problems, we know that these are both these segments here, because they go from the center to the edge of the circle. Now we know that BC is 5 and that AB is 12. So it tells us that it's a tangent segment, and since it's a tangent segment, we know that it creates a right angle right here. That has to be the case. Since it's a right angle there, we have a right triangle, and we can set up Pythagorean's theorem. In this case, though, we have, let me use the colors, r squared, so that's one leg, plus 12 squared equals, and C is this entire segment. The hypotenuse is that entire segment, so we need to add those together within the parentheses. Do not fail to use these parentheses, because otherwise we get the problem entirely wrong. R plus 5 squared, quantity squared. So remember what that means. When you square something, you multiply it by itself. Do not distribute that square. Instead, it should look like this. R plus 5 times R plus 5. That's the meaning of the power 2. Anything to the power of 2. So R squared plus 12 squared. I'll just evaluate the 12 squared. And then finally we have to FOIL the right hand side. So we get R squared plus 5R plus 5R plus 25 is all equal to R squared plus 144. What's nice is we can get rid of these R squared and we're no longer working with the quadratic. So we're not going to have to factor. So this is 144 on the left hand side, and this is, let's combine these terms, 5R and 5R, 10R plus 25. If you subtract 25 from both sides, what do we end up with? We get 119. Okay, so 119 is equal to 10R. If we divide both sides by 10, which we should do, divide by 10, then we get R is equal to 11.9. And just plug it back in and double check it makes sense. Alright. Suppose we can do this last one. AC is congruent to FD. So AC, that's this, is congruent to FD, that's this. So since we know that the chords are congruent, we know that they're equidistant from the center. So these are also congruent, these two red segments. This is the equidistant chord theorem. Now, since we know that those two line segments are congruent, the two red ones, we can say that what they equal, right? PG equals x plus 5, and PH equals 3x minus 1. Solve for x, subtract x from both sides, we get 2x minus 1 equals 5. Add 1 to both sides, we get 2x equals 6. Therefore, x must equal 3. So we have the value of x, but now we need to figure out what the radius is. So I'm going to erase this so we can kind of see what we're looking at. Well, the radius is PG plus GB. Well, that's not going to help us. PJ, what can we do? Our radius is from here to here. Oh, we know that AC and FD are 30. That's helpful. Okay, so as I originally drew, forget which color, but we'll do it in green. AC and FD are 30. So it doesn't matter which one we use for our right triangle, but if FD is 30, then JD is half of that, right? Because we also know that if this is perpendicular, PJ, to the chord, that it cuts the chord in half. So this must be 15. If this is 15, and we know that PJ is 3 times x, which is 3, minus 1, then we get 9 minus 1, which is 8. So this value is 8, and therefore we can find the radius of P, because that would be the hypotenuse on this right triangle we're looking at. So we'll just call this C. From here, you guys should know 8 squared plus 15 squared equals C squared. You can evaluate it from there.